The last section of Unit 8 is going to be talking about how we can graph sine and cosine functions. Now, when we graph sine and cosine functions, we're going to refer back to the unit circle at first to get this parent function or the mother function. And then once we establish that, we can do our translations the same way we would translate other functions. So instead of plugging in values like -2, -1, 0, 1, and 2, like we did for our other functions, we're going to be plugging in theta values for angles on the unit circle. So let's look at this table here, the parent function of y equals sine of theta. These are the critical values we're going to use because sine is nice numbers at this point. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. Now we could keep going up by pi over 2, and you will see that this function will repeat itself. Sine and cosine functions are what are called periodic functions because they have a period or they repeat themselves. So if we were to plot this 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi, 0. So it would go like this. Now, like I said, because it's a periodic function, we could actually extend it this way as well, and you get what's called a nice sound wave. And if we had more x values over here, it would repeat itself that way as well. So we have new terms. Your amplitude, that is your a value, that number in front. Well, it is an invisible 1, so your amplitude is 1. Your minimum value and maximum value come from the unit circle, so -1 and 1, which means your range is -1, 1, but those values are included. Period, this is a new term. A period is how often the function repeats itself. So every 2 pi in the x direction, the sine function starts repeating itself. And then axis, sometimes called the midline, that's where the middle of the graph is. The middle right here is at y equals 0. Now, obviously, when we start translating this, we're going to be shifting up and down. When it comes to cosine, everything is essentially the same when it comes to the characteristics. It's just our graph's going to look a little bit different because the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine or x value when on the unit circle for 3 pi over 2 is 0. And the cosine of 2 pi is 1. So when we go over here, we have 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. So don't make this a V. You want to have some nice curve to it. And then we could go backwards and follow the same pattern. And that's what a cosine graph looks like. So if you compare the two, it looks like that they're the same thing, just shifted left or right a little bit. Like I said, all the characteristics are the same. Midline again is y equals 0. And once we start shifting again, like I said, we'll have a different midline or an axis. So characteristics of both sine and cosine. The range of each function is -1, 1. The amplitude of the function's graph is half the difference of the maximum and the minimum, or this equation here. It's also the a value, the number in front of sine or cosine. Each function is periodic, which means it has a cyclical pattern. The shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called the period. That's what we're going to be referring to it as at most, and we're not going to say cycle a lot. We're going to say the period of this function. The sine and cosine graphs have a period of 2 pi because that's how often we repeat ourselves. So think about 2 pi is a full circle. So it would make sense that sine and cosine graphs start repeating themselves every 2 pi. The x-intercepts of sine of theta occur when sine is 0. So at 0, pi, 2 pi, 3 pi, and so on. The x-intercepts of y equals cosine of x occurs when is cosine 0? Well, cosine is 0 at pi over 2, 3 pi over 2. We can keep going by adding 2 pi over, we could keep going by adding pi to these. So we have 5 pi over 2, 7 pi over 2. Like I said, we could keep going, and those would be all x-intercepts of y equals cosine. And again, the amplitude changes with the a in front of sine and cosine. It's like our vertical stretch and shrink, just like how a is always affected a shrink or stretch when we've had that value in front of the function. Now the change in the period, if we have a number in front of the x, that affects our period. And since the normal period is 2 pi, to calculate the new period, it is this formula right here, 2 pi over b. And our normal critical values are pi over 2 units. So if we divide by pi over 2, if we divide that by b, that will give us our new increments, or what we're going to go up in the x-axis by. So here we went up by 0, pi over 2, pi, pi over 2, 3 pi over 2, 2 pi. Each time here we were adding the x values, we're going up by pi over 2. Those were our increments. And you can see that from our dots on the graph, that each point we went pi over 2 in the x direction. Well, if we start changing that b value, if we start changing that period, what are we going to go up by? Well, what we're going to go up by is whatever pi over 2 divided by b is. That is what we'll be going up by. And then we'll follow these steps here as we start graphing. And you'll see how all of them fit together. So let's graph some of these functions. So there we have graph the function y equals 3 times cosine of x. Your amplitude is the number in front, so it's going to be 3. Your period is 2 pi over b. Our b value is the number in front of x, so 1. So 2 pi over 1, or just 2 pi. Axis, or the midline, it's going to be y equals 0 because we don't have a plus or minus outside here. We don't have that k value. So what we're going to do, our increments, like we have up here, our increments, we're going to divide pi over 2 by our b value, and that's what we're going to go up by in our table right here. Well, our b value is 1. So our increment is going to be pi over 2 divided by 1. Maybe I can write that a little bit better. Pi over 2 over 1, or pi over 2. So my x values are going to start at 0, then pi over 2, and I'm going to keep adding pi over 2. So this will be 2 pi over 2, or just pi, and then I'm going to add another pi over 2, so 3 pi over 2, and then I'm going to add another pi over 2, so 4 pi over 2, or 2 pi. Now the y values. the y values, we have to, again, think about the unit circle. What is the cosine of 0? But then multiply that by 3, that 3 in front. That's our amplitude. So the cosine of 0 is 1, so give me 3. Cosine of pi over 2 is 0. 0 times 3 is 0. Cosine of pi is -1. -1 times 3 is -3. And then 0. And then we're back to 3 again. If it helps you to create like another row, and you wanted to just do the normal function up here, I can show you what that looks like real quick. And then 3y. If that helps you, you could do that instead. So what I'm going to do, you notice that I don't have any tick marks here. What I'm going to do is go up and plot these x coordinates. So these x values, pi over 2, pi, 3 pi over 2, and 2 pi. And my amplitude is 3. And then I'm plotting my points. So my graph will look like that. So we're basically creating the scale to match what we want. Where typically in an XY grid, you already have tick marks here. And we have 1, 3, and we plot a point, and 2, 2, plot a point. But with sine and cosine functions, what we're going to do is for each of these problems, we're going to create our scale on the x and y axis to fit our graph. So our functions are going to look the same for a lot of these problems, but the values that you see here are going to be different depending on the problem. All right, so on the next page, we have y equals sine of 3x. The amplitude in this case is an invisible 1. Your period is 2 pi over b, so 2 pi over our b value of 3, so that's our period. Midline is still y equals 0 because we don't have anything added up here. And then our increment, remember, it's going to be 2 pi, it's going to be pi over 2 divided by b. So instead of dividing by 3, we're going to multiply by 1/3, which is going to be pi over 6. So that's what I'm going to go up by each time. We're going to start with 0, pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3. Now the y values, sine starts, look up here, sine starts at 0, 0, and then it goes up, then back to the midline, then below, and then back up to the midline. So we can plug in the values if we wanted to, or you could realize or use the pattern and see that it's going to go like this. But let's look at and plug stuff in. If we plug in pi over 6 for x right here, okay, 3 times pi over 6 will be 3 pi over 6, which is pi over 2. Well, the sine of pi over 2 is 1. We plug in pi over 3. 3 times pi over 3 is pi. Sine of pi is 0, and so on. So you could use this as a nice guide, as a nice pattern to avoid having to plug stuff in. All right, so now we have 0, then we're going to have pi over 6, pi over 3, pi over 2, and 2 pi over 3. And then 1, -1, our graph's going to start at 0, 0, go up, back to the midline, below, up. So sine always starts at the midline, in this case 0, 0, and then depending on if our a value is positive or negative will depend on which direction we go. Whereas cosine will always start at a maximum or minimum depending on if our a value is negative or positive. All right, now example number 4 here. Our amplitude is 1/4. Our period is 2 pi over b, or 2 pi over pi, which is 2. Midline is still y equals 0. Now, our increment is going to be pi over 2 over pi, or multiply by 1 over pi. The pi's will cancel, and you're left with 1/2. So our x values are going to go up by 1/2. So 0, 1/2, 2 halves, or 1, 3 halves, 4 halves, or 2. And because our a value is positive, sine's going to start at 0, the midline, and then go up, up to 1, down to our midline, down to -1, and then back up to our midline. And because we have that 1/4 in front, these are going to be the y values we'll plot. So 1/2, 1, 3 halves, 2, and then 1/4, -1/4, oops. So then our curve goes like this. Now, it's important to note that if we kept going, the sine graph would go forever in both directions, but we're only graphing one cycle or one period. That's all we're doing right now. And like I was saying, like these two graphs, they look exactly the same, but it's the scale that's different. We went up by 1/2 here, where up here we went up by pi over 6. All right, our last graph today, y equals 2 cosine pi of x. So your amplitude is 2, period 2 pi over b, or 2 pi over pi, which is 2. Midline is y equals 0 again, because we don't have anything out here. And our increments will be pi over 2 times 1 over pi, because we're dividing by that, which gives us 1/2. So our increments are going to be 1/2 like they were in the problem right before. Oops. So 0, 1/2, 1, 3 halves, and 2. And the cosine graph starts at 1, then goes down to your midline 0, then down to -1, back up to the midline, and then back to the starting point. Cosine, like I said, starts at top, goes down, and then comes back up. Now, once we start translating these graphs or transforming, you'll see some differences. And then we're going to do 2y, so 2, 0, -2, 0, 2. So 2, -2, and then 1/2, 1, 3 halves, and 2. We're going to start up here, down, And our cosine graph is going to look just like that. All right, now on the next page here, we got a word problem. It says the periodic nature of trigonometric functions is useful for modeling oscillating motions or repeating patterns that occur in real life. So like if you have a tower fan that goes back and forth, it rotates, that's an oscillating motion. Some examples of this are sound waves, the motion of pendulum, and the seasons of a year. In these applications, it is useful to study the frequency of a model. So frequency gives the number of cycles per unit of time. It is the reciprocal of the period. So that's why it says 1 over the period. So it says write a sine function with an amplitude of 3, so your a value is 3, and a frequency of 1,000. So your period is going to be 1 over, so your frequency is 1,000, so 1,000 equals 1 over the period. And if we cross multiply here, we get 1,000 times the period equals 1. Divide both sides by 1,000, and your period is equal to 1 over 1,000. Okay. Now the period is also, if we know back from up here, 2 pi over b. So let's replace period with 2 pi over b equals 1 over 1,000. And we can cross multiply again. So we get 2,000 pi equals b. So our function, our sine function, is going to be y equals 3 sine of 2,000 pi times x. That'll be our function. Example 7, a sound consisting of a single frequency is called a pure tone. An odometer produces pure tones that test a person's auditory functions. Suppose an odometer produces a pure tone with a frequency of 2,000 hertz. The max pressure P produced by the tone is 2 millipascals. Write a sine model that gives a pressure P as a function of time. So our A value is 2, and we're going to have to do the same thing that we did because we have our frequency. So since our frequency is 2,000, we're going to do the same math that we did up here. So 2,000 equals 1 over the period. So if we cross multiply 2,000 times the period equals 1. Now we can do a little bit of a shortcut because we know the period is 2 pi over b. So we can make that replacement now. So 2,000 times 2 pi over b equals 1. Well, it's going to be 4,000 pi over b equals 1. Multiply both sides by b, and we get 4,000 pi equals b. So now our equation is going to be y equals 2 sine of 4,000 pi times t, because they're telling us to use t. All right, so that is it for graphing sine and cosine. It does get easier the more we do these, and we want to have this good foundation down before we start translating these graphs. So if you need to, go back and review the video to get a better grasp of how we do this. So thanks for watching. Make sure to like the video and subscribe.